Assalamualaikum and good day to our respective lecturers. We are from group 9 and in this video we're going to explain about our project. Our group consists of 4 team members, which are myself, Nomushida, and my other 3 teammates, which are Muhammad Al-Amin, Siti Nofatin and Wan Azra Aisyah.
Okay, so now we'll continue with our presentation. First, we need to know what is flash separator. A flash separator is an industrial process machine that is usually used to separate the product by its phase. We can see this flash separator being used in oil and gas industry. Okay, how does this flash separator works? The fluid is pressurized and heated before passing via a throttling device or nozzle into the flash drum. A part of the fluid evaporates due to the considerable drop in pressure. The vapor is released above, while the liquid descends to the bottom of the drum, where it is extracted. The process is known as flash distillation because the vaporization is exceedingly rapid after the feed enters the drum. Because of the tight contact between liquid and vapor, the system in the flash chamber is very close to an equilibrium state. Okay, for this project, we were required to use flash calculation to determine moles of the product stream, which are in vapor and liquid phase. So, in this equation, we can see that there are two different products, two phases, which contains the same molecule, same component, but different number of moles. Before we proceed with the calculation, we need to assume number of moles of each component and temperature of the inlet stream. Okay, so that's all from me. Now we move to the next part.
Process condition. The flash separator is designed for operation at temperature 95 degrees Celsius. Considering a solution mixture temperature of 95 degrees Celsius, which fall within the boiling point range of hexane and toluene. The flash separator is designed to operate under a pressure of 150 kPa. The assumed pressure of 150 kPa falls within the range of the due pressure 125.7854 kPa and bubble pressure 170.4321 kPa, which indicates that the assumption is reasonable and appropriate for the flash separator operation. Molar composition: 0.7 mole of hexane, 0.3 mole of toluene. Choosing a non-equimolar composition allows the customization of flash separator based on the specific properties and requirements of the substance being used.
Based on the question, the first step is to find the P set, P bulb, and P due. To get the value for A, B, and C, we need to refer to table B2. And here is the data that we get. For hexane, the value for A is 13.8193, for B is 2696.04, and for C is 224.317. Meanwhile, for toluene is 13.9320 for A, 3056.96 for B, and C is 217.625. And using the formula here, which is ln P set equal to A minus B over T plus C, then we just substitute the value, rearrange the equation, and then we can get the value of P set for toluene and hexane, which is 216.1182 kPa for hexanes and 63.6653 kPa for toluene. Move on finding the P bulb using the formula of x1 times with P set 1 plus x2 times with P set 2. We can get 179.4321 kPa for P bulb. And then for P due, we just key in the value into the formula of 1 over P due equal to x1 over P set 1 plus x2 over P set 2. We can get the value for P due, which is 125.785 kPa. After that is finding the value of K and V. First, we can find the value of K by using the formula of Ki equal to Pi set over P. And then we just substitute the value of Pi set and P. And we managed to get the value K for hexane, which is 1.4413. Meanwhile, 0.4244 for toluene. And below that is how we can find the value of V using equation 13.106. And we can see here, we just substitute the value, we arrange it, and we can get the value of V. But we need to iterate it a few times, and as we can see here, we iterate it 5 times until we get to a consistent value of V. And the final value of V that we get is 0.535.
Next, we will find the mole of liquid by using the formula L plus V equals to 1. Then, by substitute the value of V we got from the iteration just now, which is 0.535, we will get the mole liquid is equals to 0.465. Then, we will find the molar composition of vapor of hexane by using the formula Y equals to Zi times Ki divided with 1 minus V in bracket Ki minus 1. Then we will get the value of molar composition of vapor for hexane is 0.816 mole hexane per mole. Next, we will find the molar composition of toluene in vapor, which is 0.184 mole toluene per mole. Then, from value of K and Y, we will substitute into the formula Ki equals to Yi over Xi to find the value of molar composition of liquid, which is X. Then, we just substitute the value of Y and K into the formula, and we will get the molar composition of liquid for hexane is 0.566 mole hexane per mole. Then, we take 1 and minus with X to get the mole fraction of liquid for toluene, which is 0.434 mole toluene per mole. Next, we will do the molecular species balance. This topic we have learned during mass balance course in semester 2. So, we do molecular species balance to get the total mole for the outlet stream, which is N1 and N2. So, firstly, we're going to do the overall balance, which is 100 equals to N1 plus N2. Then, we arrange the equation to N1 equals to 100 minus N2. Next, we will do the hexane balance, which is the total inlet equals to total outlet. Then, we take the mole of hexane and times with the total mole of that stream. Then, we just substitute the first equation into the hexane balance equation. Then, solve the equation to get the value of N2. So, we get the value of N2 equals to 46.4 mole. Next, substitute back the value of N2 into the first equation to get the value of N1, which is equals to 53.6 mole. That's all from us. Thank you for watching.